I'm Ashton Addison from the Crypto Coin Show, and today on Blockchain Interviews we have Eric Vreeland, CSO of Polyhedra, on the show to talk zk, interoperability, artificial intelligence, of course, and machine learning. And I am excited to dive into the mixture of all of this today with someone who has been deep in it for a while. Eric, thank you so much for taking the time to come on the show.
Thanks, Ashton. Really great to be here and excited to talk about all these topics. Yeah, so I guess I'll give a little intro. My name is Eric Vreeland. I am the Chief Strategy Officer at Polyhedra, and I know strategy can be somewhat ambiguous. So I was the first kind of go-to-market hire at Polyhedra. Since then, the team has expanded dramatically. We've built out our business development, our community, our marketing functions, but really kind of oversee all of the go-to-market side of the business. For those that aren't familiar with Polyhedra, we are a infrastructure company, and we focus on building trust and scalable systems, specifically on AI and blockchain. Our first product that you mentioned was zkBridge, and it is the leading zero-knowledge secured interoperability protocol. While building that, we built our own zero-knowledge proof system called Expander, and since then have launched EXP Chain testnet, as well as have released a number of developer tools for Verifiable AI and zkML.
Amazing. And I want to dive into the zkBridge a little bit more, and maybe like a ELI 5, where it's like, there's a lot of people that are deep in it, but there's also a lot that are still, maybe they're holding Bitcoin, they're holding Ethereum, they see all these other blockchains, and they're trying to tip their toes into getting into other chains and exploring different applications. So with the zkBridge, how does that work, and what is the value that it provides in getting into these different ecosystems?
Sure. So if you're just dipping your toe in blockchain, you probably have Bitcoin, maybe you have Ethereum, but you're hearing about all these other blockchains that are purpose built for one reason or another. Maybe they have super fast throughput, or therefore securing IP, and you want to experiment with those blockchains. So you need to get assets onto those chains, and in order to do so, typically what you'll do is you'll find a bridge. And bridges can work a number of different ways. The way most bridges work, because blockchains are built to be very good at securing data within that isolated environment and making sure that that data is accurate and correct. But what they're not good at is verifying data between different blockchains. And with a traditional bridge, usually what will happen is data will be requested. You want to read data from one blockchain and you want to share it with another blockchain. And what most bridges do is they introduce this kind of validator network in the middle that signs off and says the data on blockchain A is this, and you can record it on blockchain B. And so a typical use case would be like, I have burned 100 USDT on blockchain A. This validator network signs off, yes, this action did in fact happen. Now you can mint or release 100 USDT on blockchain B. Mm-hmm. But you still have this trusted intermediary. You have this network of validators that you have to trust in order for this system to work. And I think working in Web3, many people believe we want to get to as trustless of an environment as possible. And our founders were studying cryptography and specifically zero knowledge. And then they thought that this was a really good application of zk. So instead of having to use a validator set, you can create a zero knowledge proof that proves the data on blockchain A is this. And then you can verify that proof on blockchain B. And you no longer have this third party kind of centralized piece of the bridge. And so really the advantages to zkBridge over a lot of the alternatives are just better security, more less trust assumptions, and then there are some kind of other properties of zk that make it very powerful. So you can pack a lot of transactions into one zk proof. So it is also incredibly cheap. So there are a lot of benefits to kind of zkBridge, and I think we're starting to see zero knowledge really being top of mind in a lot of different use cases because of these characteristics of data privacy, scalability, robustness in terms of security.
Definitely. Yeah, I appreciate that explanation and the differences there. And with the with just say I'm on one chain, I want to bridge, or I want to use the zk bridge. What about the user experience? You know, that I think that's been one of the barriers to entry of decentralized exchanges or decentralized finance versus centralized. People, you know, they of course there's a majority of people still that are like they don't mind using a trusted third party or a verified other source if it means that it's more secure or if it means that they have to do less stuff
Yeah.
because you know it's faster, it's more convenient, and like, convenience is key in you know the age that we're in right now. So have you guys streamlined that process of actually making it sure it's not you don't have to rely on third parties, but it's actually a lot more work? Is that the case?
It's not, no, it's not more work. From a user experience standpoint, it is, probably the same or better than the alternatives that are out there. Really, at Polyhedra, although we do have our own kind of token bridge, what we're really focused on building is that infrastructure layer. So while you can build on top of what we call kind of our general message passing framework, you can use this for all sorts of use cases. So you can use this for fungible token transfer, NFT token transfer. That's actually one use case that is very, or NFT transfer. This is one use case that's very well handled by ZK. You can also use it, to build cross-chain oracles. So it's not just limited to just token transfer. It can pass any arbitrary data between blockchains. And the user experience should be, no different or better than what already exists out there. I think, one of the big kind of roadblocks that we had to overcome was when people are bridging assets between blockchains, it can be very anxiety inducing. They click the submit, bridge assets, and then the assets leave one wallet and they're in the ether and they're waiting for it to show up on, on the other blockchain. And especially if you're transferring large amounts of funds, you can have a lot of anxiety because you're like, I hope it worked. I hope I didn't do anything wrong. And so the reason it took so long for a zero knowledge secure bridge to come is because ZK proofs take a lot of compute and generally, or until recently, took a lot of time. And so what we had to do was really start at the very bottom of the stack and build a proof system. And our proof system is called Expander, and it's now open source, that had incredibly fast proof generation times. And so we can now generate a proof of the entire Ethereum full consensus in under 10 seconds. And so once we kind of overcame that hurdle and zero knowledge proofs were no longer the bottleneck for these cross-chain transactions, now we can give the benefits of security and scalability without the downside of having to increase the time for the data to move between blockchains.
That's great to hear. And could you give some examples? You mentioned Ethereum there. If I wanted to move some stablecoin USDC from Ethereum main chain to some layer twos like Optimism, Arbitrum, Base, and in another example, maybe I want to move to other blockchains that aren't EVM compatible as much, Solana or Binance. Is all of that possible, or are you mainly focusing on the Ethereum ecosystem?
Yeah, so we definitely started with EVM. We support about 35 different networks now. Most of them are EVM. We do support, Binance, BNB chain, OPBNB, and we also are doing work on non-EVM as well. So we've been working on Solana for a while. There are some other kind of non-EVM chains that we're talking with or integrating with. So our goal is really to enable interoperability across the entire blockchain ecosystem and not just EVM. But there are complications that get added in when you're moving from EVM to non-EVM, and so it takes a little bit longer from a development standpoint.
Definitely, that's good to know. And in the last year, there's been such an uprising of actual functionality and utility of artificial intelligence into blockchain with AI and machine learning. Is there a play that adds extra value with AI into Polyhedra as well?
Yeah, so I mean, these AI agents have been kind of a hot topic for conversation, and there's a lot of teams that kind of see blockchain as and AI agents as this area that kind of blends the two technologies or works really well, because AI agents, especially if we're going to have them, go out and do commerce for us or pay for things, they're going to need some sort of financial rails to do so, and crypto is a very good system for that. But these agents also need to, if you have an agent isolated on one blockchain, it's not going to be very powerful, because like you said, there's all this other stuff going on, and there's all these reasons and benefits to different blockchains. So it is important for AI agents to have verifiable data on different blockchains. It is important for AI agents to be able to execute actions across multiple blockchains. And so we see zkBridge as a really powerful interoperability tool for AI on blockchain. There are all, we can't have, all of these different kind of isolated AIs on different blockchains. We need them to have kind of a multi-chain or omni-chain set of functionality and access to all of this data. And zkBridge really can empower that. And so we are talking to a lot of AI teams that want to tap into zkBridge for that. I would say one other area that we're really focused on is, because we had to build this highly performant proof system that was incredibly fast at generating zk proofs, we started to think, what other areas is real-time proving a necessity? And one of the areas that we are spending a lot of time and resources on is verifiable AI. So how do you know, that an AI agent belongs to a certain person or a certain entity? How do you verify that the AI that you're interacting with is, actually utilizing the AI model that you expect it to, and that it's not just, a human behind there kind of feeding it outputs? Or how do you know that the AI output generated was actually generated from the inputs that you gave it? So these are all, AI has been a black box, and we've kind of accepted at that. You give it inputs, it gives you outputs, and you can choose to trust those or not. But with zero knowledge machine learning, we can add some transparency to AI so that you can have confidence that, this output was generated from this model based on these inputs. And that opens up a whole new kind of world, and we think really increases the trust between humans and AI as AI starts to become used in everything that we do.
Yeah, that's a great point, Eric, especially because in blockchain, these permissionless blockchains, you can just go look at the source code. You can see everything. There's no backdoor. And with the LLM systems that most people are using, you don't really know what the input, and then there's something in the middle, and then the output. And I feel like if we're going to make a decentralized version of that, or at least we're going to use it with blockchain systems, this is not transparent at all.
No, I mean, and it's not efficient for us to run these AI inferences oftentimes on chain. So you're going to need to run these inferences off chain. You give your inputs, it goes to some server or some a cluster of GPUs. Those inferences are run, and then those outputs are brought back on chain, and then used in whether it's some DeFi protocol or whatever it is. And anytime you kind of move off chain and then come back on chain, there's this period of time when you don't really have that full kind of supply chain, or of what happened. And so ZK proofs really help bridge the gap between on-chain and off-chain, because you can still do this compute off-chain when necessary, but you still have this proof that you can verify and post on-chain to prove that everything, was legit.
Yeah, no, that's a great use case. And so for example, the zkBridge, using the ZK technology there, and then using ZK for verifiable AI, did you guys use part of the same like principles for it, or I feel like the use cases are slightly different?
Yeah, I mean, at the end of the day, it's kind of proving that data or computation is is what you say it is. So from a blockchain perspective, you're proving that the data exists on blockchain A, and you're proving that cryptographically. With zkML, you're proving that the AI inference happened accurately and as expected, and that it wasn't tampered with. And so at the end of the day, it just comes down to kind of proof of computation or proof of data. The key theme, and I think you're right, like these are two kind of they can seem very far apart in terms of applications. The reason that we pick them is because we believe that these are both applications where that speed is very critical. If it took 10 hours for you to use zkBridge to move assets between chains, you'd probably go and find an alternative. Similarly, if it takes days to generate a proof of accurate AI inference, it's probably not going to get used. And that used to be the case. It used to be the case that it would take, I think, for 2.5 days were some of the benchmarks to generate a proof of AI inference. And by applying expander and GPU acceleration, we've now gotten that down to an hour and a half. And with optimizations and improvements that we're making in our zkML stack, we're hopeful to get that down to sub-second by the end of the year. And so now you can actually generate an inference, and in that same output, when you give the user the inference, you can also give them a proof at the same time. And so it's these use cases where real time proving is necessary, where our technology really is beneficial. And so there are other use cases where ZK is really popular. ZK rollups are one of them. ZK rollups, you don't have to post the transactions from the layer 2 to the layer 1 in real time. If you did that every 12 hours or every hour or every 30 minutes, it would probably be satisfactory, because it's not super important for that to be real time. But for use cases like bridging, AI inference, and there's a whole self-driving cars, there are use cases where you really do need that real-time verifiability.
Definitely. And with the verifiable AI, you gave an example that the inference LLM that we're using, it might be off-chain, like most of 99% of what people are using. But I've also had a lot of discussions in the past months about decentralized AI, and maybe that's not completely on-chain, but they're trying to, pry all the people that are using OpenAI, into something that is a little bit more respectful of their privacy and the information that it's collecting. Is the verifiable AI technology that Polyhedra is creating, is it applicable to both centralized AI, so to say, and the decentralized AI as that grows as well?
Absolutely, yeah. It can be applied to across both fields. So it's really kind of it doesn't matter whether it's on chain, it's decentralized AI, it's centralized AI. At the end of the day, what we're trying to solve is, is there a need for this kind of verifiability and this proof of accurate execution?
Yeah, I love that, because most people are not using decentralized AI. At least we're still in the infancy of it. But is there an incentive for the centralized parties that run the centralizing AI to actually implement zk or verifiable AI into it?
Absolutely. I mean, so right now there's a lot of talk about, open source models, and for our initial kind of release of zk PyTorch, which is our tool that developers can use to turn a machine learning model into a verifiable model, we do a lot of our benchmarks around open source models. But one really interesting use case is you think about all of these applications where the the model itself is really the special sauce. It's like the proprietary piece of technology that a company has developed to make money. And so that could be like a financial model that outperforms the S&P. That could be a healthcare model that is really good at diagnosing particular diseases. Now, in these instances, it doesn't make any sense for the developer of this model to open source it, because that's how they make money as a company.
Mm-hmm.
But at the same time, they need to figure out a way to license usage of that model out. And typically what happens is, their customers give them the inputs, and then they run the model, and then they give the outputs to the customer. Now, in this interaction, you are really having to trust that company that they are actually running the model on your inputs, giving you the outputs. And so we're coming back to this idea of trust, right? You're trusting the company that you're interacting with. And you could eliminate the need for that trust by turning those models into verifiable models. And so, you give, now as a user, you give the inputs to the company that you're hoping to, use their model. They give you the outputs along with a proof that proves that, this model, the same model that had, these 99% accuracy on historical backtests, is being used. And so you don't actually have to give the details about the model. You can just give a cryptographic proof that's unforgeable, and it can give you the confidence that, you actually are getting the outputs from the model that you expect. And so this is kind of an emerging field called machine learning as a service that I think is going to become growing in popularity as we go from these large kind of general purpose models to maybe more niche special purpose models.
Yeah. No, I'm excited to see the growth of these small language models as more and more information that, you could be studying one specific topic for decades. And like, I don't think the LLMs that we have right now can get that deep into it. But eventually all of that's going to be input into the AIs and probably tokenized somehow and all this stuff. So we'll see how that grows. Now, with the verifiable AI technology, where exactly is Polyhedra at with that right now?
Yeah, so we published a paper on it about 2 months ago. We had done some kind of preliminary, internal benchmarking, and we just recently are kind of publishing our recent benchmarks publicly, open sourcing zk PyTorch, open sourcing a lot of the work that we've done on the zkML side, and making that available for developers. So we're constantly in talks with different teams that are building an AI, both kind of more traditional Web 2 and Web 3 blockchain AI builders. And we're kind of getting this first cohort of applications that believe in the importance of verifiability and want to integrate that into their stack.
Yeah, I would love to have that ease of use of using an AI agent that had verifiable AI to then give it tell it my agent to use the zkBridge to transfer my assets to the chain that I want, so I can start doing DeFi, or it can start doing DeFi for me. So
Exactly, that's the key, right? I think Visa published a really interesting article the other day about how we're kind of moving towards this world in which AI is going to go shopping for us. It's going to handle all paying our bills for us. It's going to automate a lot of this kind of annoying, you know, these annoying tasks and that we have to do every day. At the same time, you know, when we went from a cash society to a credit card society, that introduced a new vector for fraud. And then when we moved from, you know, kind of traditional swipe your credit card at a terminal to online, that introduced a new vector for fraud. And now as we go from kind of credit cards to AI agents that may have access to a crypto wallet or to a debit card or whatever it may be, now we're introducing another vector for fraud. And so I think it's important that we continue to focus on, while we are becoming more efficient, and these tools are definitely, you know, kind of giving us back the luxury of time by allowing us to outsource a lot of these tasks. They're also, you know, making it more complicated and making it more likely that there is, you know, opportunity for something malicious to happen. And so we need to continue to invest in these tools for trust and safety as much as we are investing in some of these like really hyped, you know, technologies that are going to improve our efficiency. We have to make sure that we are taking safety and trust seriously at the same time.
Yeah, that's a great example, Eric, because right now in inferencing and AI, you know, you can ask it, you know, plan a trip out for me, but you can't actually ask it to book the hotel, like take my personal information, take my credit card, book it for me. I still have to go to the website and type that all in myself. And then that's where the verifiable AI comes in, ensuring that if I give the AI my personal information and my credit card number, someone can't just hack into that and like book other stuff with my credit card. I think that's really important. And I feel like there's going to be an aha moment where people realize how easy it is once the AI agents can actually book stuff for you or make purchases on your behalf, that it's going to go crazy.
Yeah, it's going to be great. It's a really exciting time, you know, and I don't want anyone to think that we are trying to stifle growth. Like, we don't think that it's not like drop everything, stop everything before we need to solve this problem before we can continue to, you know, improve our AI models and our AI systems. That's not the case. I think just what we're trying to do is educate people on the importance of verifiability, on the importance of safety, on the importance of trust, and just, you know, similar to, I think, here's another analogy, you know, similar to the internet early on, before we had HTTPS. You know, we were interacting with websites. We didn't really think too much about security. We probably even put our credit cards into some very insecure websites and very insecure forms. There were probably some issues with that. Probably some people lost some money, but eventually, you know, in the background, we were developing this HTTPS technology that allowed for websites to develop, you know, a form or a way to take data inputs and encrypt it and make it more secure. And now every website that you go to has HTTPS. I think it'd be hard for you to go to one where it didn't have that added layer of security. And so we kind of see the progress of AI taking a similar path, where there will be these very kind of high leverage, highly critical tasks that, where if something went wrong, it could be, you know, disastrous. Those will be the first ones to implement zkML and verifiable AI. But, you know, 3, 5, 10 years from now, once you know the technology has improved, it's become extremely easy to implement. It's extremely fast to generate the, you know, it takes milliseconds to generate these proofs. It's going to be like HTTPS. Every AI you interact with will come with an inference. That inference will come with a proof. That proof will be instantly verifiable, and you won't even think about it anymore.
Yeah. And you mentioned earlier about the developers with the ZK Pi torch and like how developers can get involved and help build this and experiment. What about for people that aren't developers, or, you know, maybe they have done some DeFi and they experimented with different chains, they're not developers? Is there a way for people to contribute or participate in the ecosystem right now?
Absolutely. So we have, a ton of, like I said, our primary focus right now is kind of onboarding the next generation of verifiable AI applications. So one, I would just say, follow us on Twitter. We're at Polyhedra ZK. We are announcing new partnerships on a daily basis. Follow us. We also do our own kind of live uh, stream show called the Polyhedra Show, usually about twice a week. We often have ecosystem projects on there. So it's going to be, really leveraging some of the applications that are building with our technology and experimenting with it in those ways. Um, and then, yeah, I mean, if you're a developer, it would be, going and reading the documentation on zk PyTorch and leveraging that for building out your verifiable AI application.
Yeah, very cool, Eric. I appreciate your insights into where AI is at right now, how we can make it more secure with ZK and verifiable AI. I'm looking forward to seeing that in the AI platforms as I continue to get deeper in it and learn the tricks and ensure that everything's safe and secure. And I tip hats off to Polyhedra for making something that I feel like is going to be ever more important. People don't really realize yet, especially when we get transactions coming in and personal information. It's going to be so important for AI to have this technology in there. So looking forward to seeing how it all develops. I'll leave the link to the socials you mentioned, the developer docs for ZK PyTorch as well, and the Polyhedra site in the show notes below for anybody that wants to learn more about it and follow along on the socials. And I'm wishing you and the team all the best moving forward, and I would love to follow up again in the near future.
Absolutely. Would love to come back on in 6 months and show you guys all the different ways it has been applied. We've got a lot of exciting stuff in the pipeline. And then, yeah, I mean, I guess if you have any questions that came out of this podcast, you can also just reach out directly to me. I'm at Vreeland on Twitter or X. I'm always happy to interact with people in the community that want to ask questions and learn more.
Sounds great. Thank you so much, Eric.
Thanks for having me.